Okay, I'm going to have a look at two of the questions in the volumes set that you've got to do for homework, and I thought I'd do the ones that are revolved around the y-axis. So I'm doing number 10, and you've got y equals x squared, which is a function in terms of x. And when we spin around the y-axis, we need to have it as, instead of y equals f of x, we want x equals f of y. So, but not only that, we actually don't want just f of y. What we actually want in this formula, if we have a look at it, so I'll just get something to highlight. We don't just want f of y, we want f of y squared. So it's a good idea for us to have f of y squared. So x squared would be f of y squared. So that's why we're going to put our x squared in there, because we said that x squared is f of y squared. So once we've actually substituted into our expression for volume, we've got to remember we've got our limits. Now, where are our limits? A and B, that's 0 and 3 on the y-axis. And here they are here in our integral. Put it in there. We don't square the y because it's already, y was x squared. Okay, so we don't need to put any y squared going on there. So I'm just going to make a note of that. See this here? That y? That's because y equals x squared, and it was x squared that needed to go into that formula. All right, so that's why it's y put in there. Now it's just a matter of integrating. So if you've got y, raise it, divide by it. Notice that I just bring that 2 out the front underneath the pi, which you can do. And then I substitute in. So 3 squared minus 0 squared. That gives me a total answer of 9 pi on 2 cubic units. So that was number 10. I think we should do 12 together. So you've got an equation here. Y equals x plus 2. Now what's that? That is y equals f of x. And we know when we're doing volumes around the y-axis, I need x equals f of y. In fact, for my formula, I need x squared. I actually need the f of y squared. So I've got y equals x plus 2. And I'd like to get x the subject to that, so I'm going to take 2 off both sides. Okay, I've got x. See where I'm headed? See, I wanted x then, got that. Now let's go for x squared. All right, so x squared now is just going to be y minus 2 all squared. Great. So I've got my expression for x squared. Why do I need that? Because my volume formula says pi outside of from the integral from a up to b of f of y all squared dy. Now my f of y, what is my function of y? It's y minus 2. I need it squared, and when it's squared, it's y minus 2 squared. And that integral is going from minus 2 to 2. We still have our constant of pi out the front, and that's what our volume is going to be. Notice that when you do this particular equation from 2 down to minus 2, we're picking up that bit of it that's going to be rotated around, and it's forming a cone. So then it's just a matter now of doing that volume. So away we go. V equals pi. Let's integrate y minus 2 squared. So I'm going to raise it and divide by it. and the derivative of y minus 2 is just 1, so no further attention is required to fix that up. And now we're going from minus 2 to 2. Let's keep going with that. I'm going to pull out the over 3 like I did last time and just substitute in my values. So I'm going to have, well, I'll just show you what I'm doing one step at a time. All right. Put in the values, so it's 2 minus 2 all cubed minus 2 minus 2 all cubed. Now that's just 0. So volume is pi over 3. What's minus 2 minus 2? Well, that's minus 4. Cube that. So this here, that's going to be minus 4 cubed, which is minus 64. But then there's a minus in front of it as well. See, we've got to pick up this minus. So we've got a minus this. So in the end, I've got minus minus, which is plus. So there we have it. Volume is 64 pi on 3 cubic units. Okay, that should be enough to get you going. Thanks guys, see ya.